All right, I'm going to go through this pretty quickly. Please let me know if there's any parts you want me to slow down and do in more detail. All right, so we've got a pattern of squares here. I usually start with the biggest step number, and I see step number 4, I see a 4 by 4 square. And step number 3, I see a 3 by 3 square. Step number 2, I see a 2 by 2 square. So every time I see it, I see a square. That is the step number. And then I see one little dude up here and one little dude down there. So that's n squared plus 2. For question 2, we are going to do the distributive property. In other words, we're going to draw the little box. If you don't feel like drawing the box, that's okay. You can just do regular distribution. I kind of like drawing the box. I'm multiplying the outside pieces, and then I'm going to add up the inside pieces. The like terms are 2x and 9x, and that makes 11x. Okay, here's part B, x plus 4, 2x minus 1. That makes 2x squared, 4 times 2x, negative 1 times x, negative 1 times 4. Add them up, I get that. The last one, x minus 5 squared, means x minus 5, and another x minus 5, leaving me x squared minus 5x minus 5x, double negative, so I get a positive 25. So I get x squared, add the x's together, add the 25 on the end. So those are something that you can practice. Just practice, just practice, practice, practice. Make sure you remember things like the outsides multiply, and then you add the inside x's together. That's combining your like terms. Okay. Remember also two negatives multiply to make a positive. Okay. The function f is given by x squared minus 2x. If I look at x squared minus 2x, let's see. Does it have a y-intercept at 2, comma 0? No, it does not. Y-intercepts always have x equals 0. The coordinates of the vertex are at 1, comma 1. I don't know, that might be true. If I look at x squared minus 2x, I can see that that will have an x-intercept at x equals 0. Because if I make x equals 0, I'm going to get 0 minus 2 times 0. And if I make x equal 2, I'm going to have 2 squared, and that's 4. 2 times 2 is 4. And 4 minus 4 is also 0. So I can see that question D is correct. I can also see that halfway in between my two x-intercepts is equal to 2 over 2, which is x equals 1. And if I plug in x equals 1, f of 1 is 1 squared minus 2 times 1. 1 minus 2 is negative 1. So it's almost true that part B, answer choice B is almost true. The coordinates of the vertex are not 1 comma positive 1, they're 1 comma negative 1. So that one is not true. It does not open downward. In fact, I can draw the graph. Here's 0, here's 2, here's 1 comma negative 1. And it opens upward from there. Okay. We're going to graph and identify. So this will take a little bit. I'm just going to try to go very quickly through this. Again, please ask questions. Let me know if you need me to do any part of it more. So 2, 8, and negative 5 are the ABC. Because A is positive, it's an upward facing parabola. The y-intercept is negative 5. The vertex I get by doing negative b over 2a. Make sure you actually do the 2 times 2 on the bottom before you do negative 8 divided by 2. Otherwise, you're just going to get negative 8, and that's not correct. It's negative 2. And if you plug in negative 2, you can just type it into your calculator. I'll show you how to do that. We go 2 times negative 2 squared plus 8 times negative 2 minus 5. Type all that in, you get negative 13. So that gives me my vertex, negative 2, negative 13. On these graphs here, we're only asking you to really clearly identify what the y-intercept and what the vertex are. And I'm okay with you just labeling it right here, making sure that they're basically in the right spot. and then drawing something that is roughly symmetrical. We're not yet doing the x-intercepts. All right, number 2, a equals 1, b equals 4, c equals 4, frowny face shape because the a value is negative, y-intercept is 0, 4, vertex is the opposite of b over 2a. Do the bottom first. Negative 4 divided by negative 2 is 2. Type it in. So negative 2 squared plus 4, 2 plus 4. Should look like that. Gives me 8. So my vertex is 2, 8. Drawing a sketch of it. Y-intercept of 4. Vertex of 2, 8. Downward facing parabola from there. Great. All right. The next one is actually in a different format. It's in vertex form. You can see when you look at this that there's no number written at the end, and that means the k value is 0. The h value is negative 3. The shape is a downward facing parabola because it starts with a negative number. The y-intercept I get by plugging in x equals 0. That is always how you find the y-intercept. No matter what type of equation you have, you plug in x equals 0 and you get the y-intercept. If you type that in, you'll get negative 4.5. And the vertex is the h and k, negative 3, 0. So with that information, I'm able to draw a decent enough graph of it. So there's negative 3, 0. Here's negative 4.5 on the y-axis. And we're drawing a downward facing parabola through all that. Great. Let's keep on rolling. I know I'm going quickly. Just please ask me for clarification if you need it. This one's in factored form, so I have two different x-intercepts, negative 4 and negative 12. If I plug in 0, I get 4 times 8, which is 48. The vertex is halfway in between, so halfway between negative 4 and negative 12 is negative 8. And if you plug in negative 8 for both of the x's, you're going to get negative 16 for the y values. So from there, we can draw our graph. We'll just say that this is negative 4. We'll say this is negative 12. We'll say this is the vertex. And then we know that it's going to hit the y-intercept of 48. Okay, next one, another vertex form. The h is negative 3. The k is negative 5. It's a frowny face. If I plug in 0 for x and type it into my calculator, I get negative 14. And then the vertex is given right there in the problem, negative 3, negative 5. So I go like this to draw my graph. There's negative 14. We'll call that negative 3, negative 5. Again, on the actual test, I would take time to please actually put the dot where it's supposed to go. Just for the interest of this video not being a million minutes long, I'm just going a little quicker. On this last one, factored form, negative 2 and negative 8. Because those numbers make the parentheses equal 0, if I find the y-intercept, I'm plugging in x for 0 for x, and so I get negative 3 times 2 times 8, which is negative 48. And then the vertex is halfway between the x's, so that's negative 5. And what would that give me? Negative 27, I think. So negative 5, negative 27. You can use your calculator for that because you're not trying to do a speedrun YouTube video. So there's negative 2. There's negative 8. Let's see here. Negative 5 and negative 27. I think that it should be a positive 27 when we do our vertex. Yeah, I screwed up with my multiplication. So negative 5, see, don't do a speedrun video. You'll mess something up. Like that. Negative 5 and 27, and then negative 48. All right, so that's it for the graphing. Again, please let me know if any of those parts were tricky. All right, number 5. What do we got? Lynn and Claire were standing in the woods near a stream and each threw a stone up in the air at the same time so it would land in the water. The graph represents a stone after it was tossed by Lynn. Okay, so this is Lynn. And then let's do Claire's. All right, so Claire says this. Why don't we plug in 0 just to get an idea for what's going on at the beginning? So negative 16 times 0 plus a half, 0 minus 1. If you type all that into your calculator, you're just going to get, let's see, half of 16 is 8, and then make it positive 8. So I know that this right here is where Claire's starts. I also can tell from the factored form that Claire has that there's going to be t equals negative 1/2 and t equals 1 are when Claire's would hit the water. So Claire's is going to hit the water at 1. Claire at t equals 1. Claire's stone reached its maximum height a quarter second after it was tossed. That's the vertex. So let's plug in a quarter for Claire's stone. F of a quarter is negative 16, quarter plus a half, a quarter minus 1. I'm not going to try to be a hero with that many fractions going on in a problem. So I typed all that in, and I got 9. Okay, so Claire's maximum height was 9, and that happened a quarter second in. So that's not very pretty, but we're going to pretend that I drew a nice curve. There we go. It looks like it's at the same exact maximum height of Lynn's, and it looks like they both are 9. So there we go. Using some of the skills we just practiced on the graphing problems, we were able to do that word problem. Here's the last page. Okay, the quadratic function is given by f of x equals ax squared plus bx plus c, where a is not 0. So we have a quadratic equation, and it's in standard form. So what do we know? The y-intercept is at 0c. Yes, if I plug in x equals 0, then the first part's 0, second part 0, and I just have c. So that one is true. The graph has an x-intercept at c comma 0. That is not true. I haven't even taught you how to do x-intercepts from standard form. When a is negative, the graph opens downward. That is absolutely true. That has been true. Anytime a has been negative, it's opened downward. The graph has 2 x-intercepts. That's not necessarily true. We've seen some graphs that hit it twice, some graphs that hit it once, some graphs that hit it once, twice, or 0 times. And the last one, if b equals 0, then the vertex is on the x-axis. And this actually turns out to be true. If you have b equals 0, then your equation just looks like this, ax squared plus c. And this just makes it stretch or flip. And then this c just makes it go up or down, like where the y-intercept goes up or down. And so if that's the case, then you're either going to have a parabola looking like this, or maybe looking like this. And so the vertex is on the y-axis. So 3 correct statements there. We are almost done. Here's the graph of a quadratic function, and we have to figure out what could define it. Well, when I look at it here, I see 2 clues. I see the 2 x-intercepts. And when I look at the x-intercepts, I can write x minus 2 times x minus 6. When I look at the vertex, I see a different clue. I can write, I guess I could put a y equals in front of it. When I look at the vertex, I can say x minus 4 squared minus 4. But the other question is, how could I get a standard form equation? Because I see this one right here is my vertex form. I see this one is my factored form, but I don't see a standard form. So what I'm going to do is I'm going to take my factored form and multiply it out. X squared, negative 2x, negative 6x, positive 12. Add my x's, just like we practiced earlier, and I can see that this is the correct answer. By the way, just as a bonus fact, you could have taken your x minus 4 squared like this, and done x times x, x times negative 4, x times negative 4, and negative 4 times negative 4, and you could have gotten x squared minus 8x plus 16. And you might be saying, well, that's different because I thought that we had 12 instead of 16. Well, the way that you get down to 12 is you bring your negative 4 into the problem, and you can see that 16 minus 4 also makes 12. So there you have it. Again, that was a speed run. That was very fast. Please let me know what you want me to go over in more detail. Happy to do it.